Let me share the screen. All right, so homework for today was to complete the extractors and predicates that we started working on as we start working towards our first interpreter. All right, so let's finish that. Then I want to show as we start, well, there's kind of two things we're going to look at. One is, and we add it to the notes so I don't forget. Parse expression versus unparse expression. Yeah, let's go that route. All right, so let's finish writing these. So last time we re-put our environment in here. And then so we have all of our abilities for our environment down here. We also created something for a stack. That was another example, right? So actually this can go. I don't think I use that stack anywhere right now. That was on our push pop peak example. Okay. So then we have our constructors for our grammar. So right now we have three productions in our grammar. We have a Var expression, we have a Lambda expression, and an app expression. So constructing a Var expression requires exactly one parameter, and we wrap it in a list called Var expression with a Var expression at the beginning. Lambda expression takes two parameters. It takes the parameter, the single parameter, and the body. So this is going to take in we'll build a list out of those pieces. App expression takes in the Lambda expression and the parameter value, the single parameter value. We're still dealing with our simple version of our Lambda expression, and it builds that guy. So these are our constructors. So now for our extractors, we have we started writing this. So we have our Lambda calculus expression to type, which will take in any kind of Lambda calculus expression, and it'll give you the type of expression. It is either a Var expression, a Lambda expression, or an app expression, right? So this guy allows us to extract the type of an expression given any kind of expression. Similarly, we have a Var expression to Var name that takes in something that is a Var expression and returns the variable associated with it. So next extractor would be for our Lambda expressions. We probably want to have an extractor for the parameter and an extractor for the body. Make sense? Okay, so we'll have a define Lambda expression to, why don't we call it parameter? Parameter name, parameter name. Good enough. This will be a Lambda that's going to take in a Lambda expression. And it's going to, and remember, a Lambda expression is a list containing 3 elements, right? Based on our constructor. Lambda, the symbol, so this is going to return the car of the cutter, the catter of that guy. So the catter of our Lambda expression. And then we also have our Lambda expression to body. This is the body of the Lambda expression. And this will return the car of the cutter. Okay, so that's that extractor. All right. Oh, and just so I don't forget, I still have to figure out what Thursday's class needs to look like. We won't be able to have normal class time. I'm thinking that we'll move it to the morning. And if you can't make it, I'll just have the recording. But I got to see who else is scheduled in this room. So if somebody else is scheduled in this room, it might need to be just online in the morning. So I'm thinking it would be like an 8:30 a.m. Well, not at Mrs. Chapel then. Let me figure it out. let me figure it out when it needs to be, and we'll make it work. Maybe we'll do an 8, like an 8 to 9:20. That gets us done in time. Let's plan on that. Thursday at 8 a.m. we'll have class. I'll find out if we can have it in person here in class. Otherwise, it'll be online. If you can't make it, I'll record it regardless. All right, that's this for this Thursday. Our class is at 8 a.m. instead of 1:10 p.m. just for this Thursday because I have an event I have to get to. Okay, and I'll put an announcement out about that just since I only said it in passing here, but that sound reasonable to us-ish? Okay. So lambda expression to body, that gets that extractor. So now we need to look at the extractors for our app expression. So app expression is built out of a lambda expression. So it's going to allow us to get the lambda and then the parameter value. So we'll build the extractors for that. So define app expression to lambda exp. This will be a lambda that takes in an app expression, and it's going to return the catter of the app expression. That's the lambda portion of it, is the catter. Then we'll have a define app expression to parameter input. Will be a lambda that takes in an app expression and boils down to the car of the cooter of our app expression. And remember, we'll need to update these as we add in a more flexible lambda that has 0 or more parameters instead of exactly 1 parameter. That'll impact both app expression and lambda expression. But if we rate everything in terms of our extractors, then we'll only need to fix the extractors and our constructors. We won't have to go in and change a whole bunch of other code. Make sense? Okay, so that should be it for our extractors. Then we want to have predicates for these, so only 2 more predicates to determine. We already have something that allows you to extract the type given it. So actually, we probably should use our type guy here. If you didn't, that's fine. So var expression should be if our lambda calculus expression to type of LC expression, if that guy is equal to, let's call it var exp, that guy. So we'll actually use our extractor to extract the type and then compare the type to what we are interested in. So that's for our var expression. App expression. Lambda expression. All right, look pretty reasonable. All right, so now we might say, well, why do we have all these tools? It seems pretty granular to be able to do this stuff. The idea is that we build everything in terms of our primitives. We're effectively building primitive types into our language. We do everything in terms of our primitives. We make our language easier to expand. Because you can imagine that when you build a programming language, I mean, you've seen this with Java over the years where, you know, certainly with Android was extra bad, right? Every 5 seconds there's a new version coming out. You know, these are things that we want to be able to expand when we need a new, quote, magic trick. So think of a programming language as kind of like a processor. We need to add another magic trick that makes our, you know, life easier or whatever it is. You know, we should be able to easily expand our language with minimum impact on the rest of it. We don't want to have too much, too many things that break when we make a small change. So this is kind of an idea on regression testing and saying, okay, I'm only going to break certain things when I make my change. And actually, you can see all the places you could actually break one of, if you build everything in terms of your predicates and your constructors and your extractors, you could purposely break an extractor so that it shows you all the places in your interpreter that rely on that extractor, and then go and fix those specific places. So, you know, you kind of say, okay, well, we'll remove a parameter from this so that every place that uses it breaks, and I can go and at least investigate those places and see, does something need to change logically when dealing with these? For instance, when we think ahead a little bit about our Lambda expressions, when we move from exactly one parameter to having multiple parameters or even 0 parameters, that's going to change the way we execute a Lambda expression. That make sense? All right, so that's our all these tools that we should use to build these things. Now, when we write our code, pick your favorite language, Java, Python, whatever, we write our code in a certain way, but do you think that the code gets stored in that way behind the scenes, or do you think it kind of gets reformulated or reorganized in a way that's maybe easier for it to work with? Probably the latter, right? All right, so if we were to create a syntax for our language, so right now we're implementing things on top of this concept of lambda calculus expressions. And you've maybe seen in some other languages, a lot of languages have this idea of a lambda in it. But until now, you've probably either never or very rarely written something called a lambda in any programming language, right? You always had some kind of friendlier syntax, less intimidating syntax or something like that to use. So something we need to decide on here is, what does the syntax of our language look like? So right now we know how to do 3 things, right? We know how to resolve a variable. We know how to write an unnamed function. We know how to call an unnamed function with a single parameter. Make sense? These are the current magic tricks that we know how to do in our, we haven't implemented yet, but we kind of know what they're supposed to do, because we've seen schemes implementation of this. But maybe we say, look, this is our own language. We're not just reinventing scheme here. How do we write our language such that we can write it in a way that makes sense to us? And then under the hood, our interpreter can deal with this in whatever way makes the most sense for the interpreter. Now, we should probably still stick to list-based, since lists are very easy to work with in Scheme. If we were working with Java or something like that, we could say, well, we can let our syntax be strings or something. And that's possible in Scheme. We can use a symbol-based thing and write kind of like Java code and have it turn into an interpreter. But since that's not really our focus, let's stick with lists. I think that will make life easier. So, you know, at this point, a variable name, I think, you know, makes a reasonable sense. Just that we just give it a name. There's not much syntax to that. When we start defining variables, we might change that idea. But if we are creating a function, which Scheme calls a lambda, maybe we want to have a syntax for that that's a little bit different, right? You know, when we write a function, you know, we can decide how do we want our code to look for a function. So Let me just create a slide for this. So this isn't how we're going to parse it behind the scenes. This isn't how we're going to work with it behind the scenes, but what do we want our syntax to look like? When you write your code in our language, we have to come up with a cool name for the language at some point too. It should take votes. But when we write our code and we define a function, we know what a function is. But for instance, in Python, the syntax for a function is we put def followed by the function name, followed by an open parenthesis, followed by the parameters. Now we're doing this in a list format for ours. So, and we're not quite at the point where we know how to store functions yet, give names to functions yet. We'll get there. So in terms of defining a function that's not associated with a name, what do we want our syntax to look like? We know we have to have two pieces, right? We need to have what it's expecting as input, and then what does it do? The logic after the fact. So is there a interesting way that we can write that that we think makes extra sense? Let's say we're creating a programming language for beginning programmers, and we want to make something that is maybe a little bit less intimidating, still list-based because we're going to make sure we're sticking with lists, but less intimidating. You know, for instance, we could say that the word lambda is intimidating, right? It feels cryptic. So probably steer clear of that. But what might a function look like to a beginner if you're trying to teach them a function? So we have our syntax. There's our opening and closing parentheses because we're going to build it inside of a list. So I'm creating a function that takes a single parameter and let's just say outputs that parameter. Just boils down to that parameter. So I'm effectively doing lambda x x. That's the scheme syntax for this. What's our syntax? What's our equivalent syntax for this guy? Well, right off the bat, we could evolve it a little bit. Maybe we say, well, maybe this is called a function. And, you know, we could say the function boils down to, I don't know, something like that. Right off the bat, that probably looks a little bit less intimidating. Okay, well, is that good enough? Or do we want to have something, I know some other like beginner languages have something called a behavior. Maybe we create a behavior that takes an input and then does something with that input. We give a little bit different, but in this case, input is, we still have XX. So maybe the question is behavior a friendlier way of talking about what a function is than function? Function's definitely friendlier than lambda, right? So which is better, function or behavior if we're teaching this to a kid? Or something else? We got another suggestion? You like function? Okay, so we're going with function as our syntax for functions rather than using lambda, even though under the scenes, we're gonna represent this as a lambda. We're gonna, when we wanna create a function, we're gonna say, I wanna have a function that's gonna take this parameter and do something with it. All right, that's our syntax. So, well, eventually when we're able to store functions in our environment, we'd want to have a name. Right now, we don't know how to do that, but absolutely, eventually. So really, this is our syntax. This would parse to a lambda expression. And let's see, our lambda, it's going to be a list that takes in that, and would have var exp. We're leaving it. Oh my gosh. Wish you could just like turn that off. There you go. Okay. I think something like that. So we might write function XX. and that's going to get parsed into our Lambda using our constructors, our Lambda that then takes in our, has a parameter and has the body, those pieces. Go ahead.
I'd like to start
a movement, okay?
Let's just make it fun instead of function. It'll save time.
Fun? Is it fun or is it funk?
Ooh.
So fun?
Like if we're programmers, we can go and talk shop and say funk really fast. Like someone you're swearing.
So you want to stick with funk?
I don't know. Either or. But it'll just save some typing.
Okay, fair enough. Fair enough. All right, so that's what our syntax looks like initially. We'll have plenty of opportunities to invent new things as we go. But ultimately, under the hood, that needs to get translated into this. So we have this idea of parsing and unparsing our code. That is, we write code as humans. That code then gets parsed into a format that is usable by our interpreter, in our case here. So let's say we write code that then gets parsed into a format that is compatible with our interpreter. Our interpreter should be able to convert its parsed syntax back into unparsed syntax. That is, we'll just say in our case, human readable. All right, so this is our funk that we know how to do. And we know how to define, this is our Var expression, but that's not something we need to really give a name to. Var expressions just kind of exist on their own. Okay, what about app expressions? Is that something we need to give a name to? I think maybe. What's the purpose of an app expression? Look it up, just tell me. What do app expressions do? They apply lambdas to inputs, right? So an app expression is a call to a function. It's doing something, right? We're applying a function to some inputs. So app expression this is when we're actually taking a function and doing something with it by associating it with inputs. What might we call that in our programming language? We know how to define a function using func. We don't know how to save it yet, but we know how to define it. Now we need to know how to call it. So when we're calling a function, what might we say we're doing? Again, remember, we're trying to create this maybe for beginning programmers, so it kind of makes sense to them. So we have functions that do things, and they exist on their own, right? If we don't call a function, it's an untapped resource. But now I want to actually take this function that exists, whether we got it out of the variable environment eventually, or we just have it passed to it, right? But I want to call it. So when we're calling a function, you know, the book might say we're applying a function to an input. What's maybe a simpler or a better way of saying that to, as a public programmer, we're teaching beginning programmers how to use our syntax. Run? Okay, yeah, I like that. So an app expression is going to be run, and this guy is going to require us to pass it a func and parameter right now, right? Run func on parameter. You can actually even write it like that. You can even have the word on in there. I don't know if that kind of goes against your movement of shortening things. func up.
Or you can make it all.
Or with parameter. We don't have to have anything in there. This is your syntax. You like the with? Run func with parameter. Okay. So the with is, you know, we would call that guy kind of wasted space, but it is does tell us something about what's happening, right? Kind of a little bit of a verbose syntax, but not without reason. Okay, so we're going to run a function with a parameter. Okay, good. I like that. So if we were to parse a app expression and we had this type of thing, it's going to turn this guy into a app expression with a lambda whatever the body ends up being. I'll just put placeholders for right now. And then we'll say, well, actually it won't be a with, it'll just have parameter. It'll turn it into something like that. So we want to have the ability of writing code in our syntax and turning it into something that our interpreter can run. So our interpreter is going to run off our Lambda calculus expression grammar. So that's the guy that is our scientific computing, that's our language. Is our grammar defines our language. And right now we're operating off the book's grammar of this Lambda calculus expression. But we want to put a layer on top of that that says, ha, this is a nice friendly language for beginning programmers, and what happens behind the scenes doesn't really matter. Make sense? So we need to have the ability of parsing an expression and then unparsing an expression. So we're going to call this guy parse/unparse. And I'm going to put some reminders in here just so we kind of know what our syntax looks like. So we have this idea of a I'll just steal our normal syntax. So run a func with a parameter, where really the func would be this full-on thing, because we have to provide it the entire function since we don't have a way of resolving variables in an environment yet. Well, actually, we don't have a way of storing functions in an environment yet. So we have to give it the whole kit and caboodle at this point. But we can run it with the parameter, and potentially this guy could be something stored in the environment. All right, so that's some syntax that we have. And then for a variable, maybe we do want to have something saved for a variable. As a programmer, we maybe say, well, you know, it just really needs to be the identifier, but do we want to have a syntax for flagging something as being a variable? So for Var expressions, if we just write A, what are we intending to do with an A? Resolve this variable to its value? All right, so maybe instead of just having a variable sitting there, maybe we have something like look up A, something like that. Isn't that what we're effectively saying? I've remembered something at some point, right? We don't have a way of defining variables yet, but somehow variables exist. And we do have that. We have a variable environment that allows us to force variables in that we can use. And when we want to get the value of A, we really want to look up A. Or are we better off saying get the value? Get the value of. Which do we like up better? Get the value How about get value of a, I don't know, what syntax do we like? What syntax will we not hate ourselves for picking? But we still want it to be, you know, something that could be instructional to beginner programmer. Nothing says we can't just have an A sitting there and just say, well, that just means look it up. But one of the questions when you think about learning programming is we say, well, how do we know this is a variable? Well, it doesn't have double quotes around it. It doesn't have single quotes around it. Must be a variable or a mistake, right? So what do we do with variables? Well, we resolve them. We look them up. You know, we get the value associated with that variable. So if we allow them to kind of speak in more English-like, we want them to, we know we have a variable stored in we know we have a value stored under the name of a variable. And what do we want to do? When I want to get that value, I want to either look up that variable name. I want to get the value of that variable. I want to, you could just say get value. I don't know if that's as good. What do you think? You like get value? Is it get value of or just get value? Is it connected? Not connected? How about just get value A? You think it's better to look up? All right, so we have get value of A. So we're actually going to have this guy also be our var expression. That's how we say, when I want you to do this, I want to get the value of this and then have it be used in a second. Okay, so we're going to have a parse expression that's going to allow us to take something in our syntax and turn it into something that is in a different syntax. So we'll define parse expression to be a lambda that's going to take in a, what do we want to call her? Do we have a name for our language yet? We could think about that.
We could be like Washington, who's calling team or call our language programming.
Just code? It's like a cool way we can write code. Yeah, with a zero. That. Is that our language? All right, well, we should all think about that. For right now, I'll just call it code like, actually, for right now, just to remind us, we're going to call it code like that, which will be very difficult to type. Okay, so we'll eventually get tired of that and look for an alternative. But for right now, it's just this is our code, okay? And our job is to take whatever that code is, our list-based syntax that we've invented, and turn it into our Lambda expressions here, okay? So we have these, well, let's actually start down it, then that'll ask this next question. All right, so we're gonna have a cond. Now, if I'm going through this, we might be dealing with a var expression, which means that, now any way you cut it, we're dealing with a list, right? So we know we have a list, so we know it'll have a car. If the car is get value, that means we must be dealing with that kind of. So if equal car code, if that is get value, all lowercase maybe, then what do we want to do? What are we creating? We're creating a var expression, right? And our var expression constructor looks like this. var expression, we pass it that single parameter and it creates a var expression for us. So we will call our var expression constructor, passing it the car of the cooter of our code. That's what we get if we are parsing a get value into a var expression. Otherwise, if the car of our code is a run or func, maybe func, do func next. If it's func, then what are we going to do? We're going to build a lambda expression, and a lambda expression requires two inputs, right? Our constructor for that guy. Lambda expression requires the single parameter input and then the body. So we are taking in, here's our parameter there. Now, we put in the parameter list like this. Is that the way we still want to write that? Or do we want to write this guy differently? We could just put that and say the next guy is the parameter. We could say with params, and then have this guy take in this list X. Then we could say with body. So this is kind of our syntax. And maybe in the past you've heard me reference like Objective-C. Objective-C is a very verbose language. And at first it kind of feels like for example, let's say we're creating an instance of a number of dice or something like that. Let's create a slide here. So maybe in, call this a dice object. So maybe in Java, we say dice D is equal to new dice, and we say that this guy is a six-sided die. Something like that. In Objective-C, we might say dice pointer D is equal to something like that. We'll allocate some memory, and then we'll initialize it with a number of sides of 6. Now, certainly that second one took a whole lot more typing. But isn't it also more expressive? And we can make a guess at what that first thing means. And most of us coming from a background of Java, Python, C#, whatever, prefer the first one. Like, well, I don't want to write out a whole sentence every single time I type something. But when you actually just look at that second code, once you get past the allocate thing, it's the new, because it does look a little bit cryptic, especially with the square brackets. But when you just look past that and you say, oh, I'm initializing this with a number of sides. That kind of makes sense, doesn't it? So when you read that, that might be friendlier to a new programmer, even if a experienced programmer doesn't like the way it looks. Make some sense? So if we are creating our code over here for our func, do we want to be more meticulous with, actually this guy right here, func. Do we want to create a function with some parameters stored inside of this list and then with a body stored in here? Is that advantageous to us? Or maybe instead of body, it's with logic. Okay, so func has that. How about func gets this, does this? We like that one? I don't like any of them.
Good answer.
That's, what does Noah's dog think? All right, we're going with it. All right. So func gets this. So if we are looking at something that is a func, we know that our list looks like this because it's a verbose way of exploring it. But now we need to pull out those pieces. Now, we could make the argument, well, why don't we have extractors for our language as well? And realistically, we probably should. So I'm going to write this without extractors first, and then we'll add in extractors and rewrite it with extractors. All right. So Lambda expression. If I'm dealing with something that's a func, my Lambda expression constructor requires me to give it the parameter, the single parameter, not this list. So in order to get this single parameter, I need to do what? I need to take the catter, which gives me that, and then I need to take the car of that. So it's the CAADR. Of my code. No, I'm doing this one right here, right? Yeah, so this would be the code that gets passed in. If the car is func, then I know I'm going to be building a Lambda expression. My constructor for my Lambda expression is up here. I need to give it two pieces of information, my symbol, which is my one parameter right now, and then the body. All right, so we'll go ahead and give it the, I gave it the symbol right there, but now for the body, that is going to be this, the does X. So this is the cooter. So one cooter gets me here, another cooter gets me here, another cooter gets me here. So actually this is two Ds, right? The car of the car of the cooter of the cooter. Cooter gets me here, the second cooter gets me here. The car of that gets me this. The car of that gets me this. Oh, then with that in mind, for get value, oh no, we're okay on get value. That's this one. Okay, so that gets me my parameter for my Lambda, but now I need to get this piece. So that piece is the, I'm sorry, this piece right here that does X. That piece is the one cooter, two cooter, three cooter, four cooters. And then I need the car of that. Which will give me my code, right? So cooter, 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 car gets me X. What kind of animal is this guy? Okay, and what is he? If you had to identify him, his DNA, what kind of element is he? Well, hopefully, if we've written correct syntax. But is he a Lambda expression yet? Who wrote it? Humans. What kind of stuff do humans write? Code. Or how do you want to pronounce that? Until you come up with a better name. And what do I do with code? I call parse expression on it. What goes in here is going to be the parsed version of whatever that expression is. So I'm going to call parse expression on this guy. And that's what will complete my constructor for Lambda. Because the second parameter for Lambda is expecting me to give him an actual, true to life lambda calculus expression. Well, yeah, that's what he's expecting. And how do I get a lambda calculus expression from code? I call parse expression on it. Make sense? All right, so here's my call to my lambda expression constructor, passing it my variable name. And notice how we're getting these things are getting a little bit out of control here with all the blah, 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 blah. Why some extractors might be helpful. Okay. So that's what we're doing when we're looking at this. Now, if the car, now we could actually just say this one as an else, right? Because we only have three kinds of grammars right now, or three kinds of productions in our grammar, rather. So we have a var expression, we have a func expression. Well, we have a get value, we have a func. The last one would be a run. I'm actually going to be explicit. So car of code is run. If that's the case, then what do I have? I have something that has a function, and that function is written in code, right? And that guy lives at, so we're going to go ahead and we're going to create a app expression. That's the kind of thing I'm making, right? I'm constructing an app expression. This guy requires a lambda and a parameter value. All right, so I'm creating an app expression. And I need to give it my lambda. My lambda is going to be the car of the coder. Of code. But what do I want to do with that guy? I want to call parse expression on him. Because even though I'm expecting that the human being wrote some kind of function in there, right? Because I'm applying a function to a parameter or to an input, I have to parse that code function into a lambda calculus expression. Make sense what we're accomplishing here? All right, so I'll build an app expression, and the first parameter to that will be whatever parse expression returns for the function part of that. That is this guy. And then my parameter. What are the possibilities for my parameter there in my current grammar? Could it just be a 3? Or does my grammar not support that? See, we're at odds. We're too advanced programmers to recognize how wimpy our language currently is. We don't have anything called a literal expression. I can't just hard code a 3. It's not a thing. So the only thing that guy can be is a var expression. But at the very least, he's another kind of lambda calculus expression. And he had to be written in code. And what do we do to code? We parse it. So I'll call parse expression on this piece. And then I'm going to call parse expression on the next piece, which is this guy here, the parameter. So that's going to be the, so this is the coder gets me here, coder gets me here, 3 coders car of 3 coders. Should be the name of a book, the car of 3 coders. What's up? By Hemingway. Car of 3 coders. That's a good one. All right. What time are we out? 25? Okay, good. At least I asked this time and said instead of being 5 minutes over. I'm improving. All right, so that's what we'll do if we're dealing with that. Now, I'm pretty sure cons will not require us to have an else. Oh, of course it's not. Of course it's not. That guy's not, the CAADR is not defined. Ay. So I need to take the car of the car of the cooter of the cooter. Ay, ay, ay. So this is the car of the cooter of the cooter of the cooter of the cooter. All right, there we go. Beautiful. All right. There is something called list index that might actually make that a little friendlier, but this looks way cooler. So just kind of roll with it. Once you write your extractors, you can do what you want if you want to write it clear. All right, so that's our parse expression as of right now, which means I should be able to define my code. And this guy is going to have, so let's write some code. So maybe I say I want to run a func that takes in an A and does something with that. Right now, the only thing I could possibly do is just boil down to A. So what I would do is I would say get value A. And I'm reliant on a variable environment here. So I would say get value C, let's say for now. So I get whatever the value of C is from the variable environment, pass that in as a parameter as A, binding it to A, then calling, actually, can I just do a lit value there? Technically, it's not one of our productions, so no. It's unfortunate, but we can fix that soon. All right, so we will run a function that takes in a parameter and gets the value of whatever that parameter is. And then this will, then the second element here will be a get value of C, and that's what I'm running. So that's my code. So I'll call parse expression on my code. Oh. It should be actually. Oy. Poke the hole. think that will make it nicer. Do I have an extra cutter in there? Let's look at what this guy here looks like on my code. Oh, it'll be deeper in. I'm skipping past that because that's not part of our lambda calculus expression. So I'm trying to skip past that. So if I'm looking at a func, I'm building a lambda expression out of the, so here's my, oh, I do, yes. Func with, thank you. So I've written bad code. So let me back up here then. So this is run this func with, and then my func is func gets. So we're having to learn a new language here. That gets that, and it does. Actually, I don't think I need the, so I quoted the whole thing. So I don't need the single quotes before it. Okay, is that correct code syntax now? This gives us an app expression that has a lambda expression that takes in an A, whose body is a var expression, and we're passing it a var expression C. That looks right. Okay. I'm going to steal this. Actually, we'll go ahead and write unparse expression. We got time? Yeah. So I'll write unparse expression. Unparse expression should undo a parse expression, turning it back into its code equivalent. So this guy's going to take in a lambda calculus expression, and it's going to turn it into a code expression. So we'll have a cond. So we're going to ask ourselves, now we'll go ahead and use our extractors for this. So if our lambda calculus expression type, actually we don't even need to use that. We're going to go ahead and ask, we're going to use the predicates. So if we're looking at a var expression, so if our lambda calculus expression is a var expression, what do? Well, we're going to be doing one of these guys, the get value, given the, we need to extract our piece from it. So we'll say we're going to create a list containing get value, and we're going to use our extractor for our var expression. Var expression to var name. Of our lambda calculus expression. So that's what we do if we're dealing with a var expression. If we're dealing with a lambda expression, We create a list containing func. Gets. And then I need to have a list that contains, I need to get the parameter of this guy. So my extractor for a Lambda expression, this is my parameter name. And then I have a, not a with, and I have a does. And then I need to get the body. So I need to use my extractor for the body. That's what I'm looking at for my unparse expression for Lambda expression. Otherwise, I must be looking at an app expression. Lambda calculus expression. And what will I do with that? I'll create a list containing run. And what am I running? I'm running the func. So I need to call unparse expression on the unparse expression on the app expression, Lambda expression portion of this. Take this down there. And then I need to call unparse expression on my app expression parameter input portion of it. Run this with this. So I need to throw a with in the middle there. So that should handle our unparsed expression. So we'll go ahead and I'll just spit out my code. Then we'll spit out unparse expression of parse expression of my code, and we should get the same thing. Oh, I didn't call my Var expression on, this is my body of the Lambda. Yeah, I need to call unparse expression on the body of the Lambda. There we go. So now we have a parse and we have an unparse. Make reasonable sense? Does it make reasonable sense why these exist? I mean, right now, the kind of the funny part of it is that we're more used to writing the scheme stuff than we are writing the language we just invented this class. So we're having a little bit of trouble with our own syntax that we're writing and inventing at the same time, which is kind of fun. But the ultimate idea here is that the way we need to represent things behind the scenes, or the way that it might make sense to represent things behind the scenes in a programming language, doesn't necessarily jive with how we might want to write syntax as a human. Now, admittedly, we are being a little bit more verbose here to really drive the point home of what these different pieces are. So part of it is, hey, we're writing this for a beginning programmer, but we're also writing this to be like super explicit. All those things that, like, when I'm going through stuff, I say it out loud, or like we're having to write it. These are my inputs. This is what I'm applying it to. All those things, we're having to write it, which is going to be inconvenient, but is really going to drive the point home of the difference between syntax that should be English-like and the interpreter side of it, which needs to be computer-like. And how do we move between those two to keep everybody happy? And that's effectively what we're accomplishing here, right? Okay, so I'll give you this as a starting point. Code from class 929. And I'll write the homework in here as well, but I'll also put it on the Blackboard. It's just, so homework is to add the extractors for our code language that allows us, well, let's say it's code language, and update parse expression to use them. Also suggest a good name for our language. And the evidence here is if we go down here and we look at parse expression versus unparse expression, this guy starts getting crazy pretty quickly, right? With all the cars and the coulters and all those things. So being able to hide those inside of our extractors would be handy if we had a set of extractors for our code language. All right, because you saw as I was building this unparsed expression, we built that much quicker, didn't we? In terms of those extractors, I was copying and pasting the extractors. The hardest part of this was remembering when to put in our place filler words, our meaningless words that are part of our syntax. Like, oh, a with goes here, a does goes here, you know, those kind of things. That was the hardest part of that. So realistically, you could also create constructors for these guys that would give you that syntax. Now, having said that, if we want to think about our language, I'm only assigning the extractors. I think the extractors will be handy. Constructors aren't really handy because constructors are a programmer side of things thing. Human beings are constructing it by writing the words. We're not going to be using an additional tool to construct it. So a constructor could make sense for our unparse, but realistically, unparsing is more of an exercise for the language writer for us than something that's actually something that would really exist, right? We're just proving that the two are equal to each other by writing unparse of our parse. Because typically once the person writes their Java and they compile it, it doesn't go back to Java at some point in the future, right? They want the program to run. It turns in a bytecode, it runs, and they're happy. If they're going to edit the original code, they go back to the file that they saved, edit it, and recompile it. So this unparse thing isn't necessarily a useful tool other than being able to work with our grammar and the difference between our grammar and our language syntax. All right, that makes some sense? All right, so come up with ideas for a good name for a language. That doesn't have to be part of the assignment. Just I'll ask you at the beginning of class next time so we can update it before we get too far in. But write our extractors to familiarize yourself with our syntax. And then we're going to start writing some abilities to actually write code that actually does something starting next class with literals and things like that. Remember the plan for next class, I'll say it out loud again now, but I'll also post about it. Here, I'll put it on Slack as well while I'm saying it. The plan for class on Thursday is to meet at 8 a.m. at least on Zoom, but I will see if the classroom is available for in person. This is just this coming Thursday. What is that, October 1st? Yeah, so this won't be like future Thursdays, just this one Thursday. I don't want to cancel class again since we missed last week. So if you aren't able to make it in the morning, I will record it. I apologize for the inconvenience, but I don't want to miss class again. If that is some sort of compromise, I guess. Okay, I will see everybody on Thursday.